Okay, we're going to look at systems of equations. Now, I know in the previous sections you've looked at two equations with two unknowns. Now we're going to look at three equations with three unknowns. The easiest method to solve a system with three variables is to pick two equations and eliminate a variable. Then pick another pair of equations and eliminate the same variable. So for example, we have three equations here. And I look and I say, you know what might be the easiest variable to eliminate? X. Okay. So what I'm going to do is I'm going to take equation 1 and equation 2 and we're going to eliminate X. Then I need another pair of equations to eliminate the same variable. This process will not work if you eliminate different variables. You have to eliminate the same variable from each pair of equations. So I decided in advance I'll eliminate X. Now the next thing is, let me eliminate X from equation 2 and equation 3. That's going to end up, as you'll see in a moment, giving us two equations in both y and z. Okay, so now what I did is I took equations 1 and 2, x plus y plus z equals 6, x plus 2y plus 3z equals 14, and remember we said a minute ago we're going to eliminate x. And so I took equation 1 minus equation 2. So remember, you have to distribute the negative sign. So equation 1 and equation 1 now minus equation 2. So again, we have to distribute the negative sign. So we get a negative y minus 2z equals negative 8. Okay. Now, we take the next two equations. X plus 2y plus 3z equals 14. 2x plus 3y plus 2z equals 14. Now again, we want to eliminate the x. Now this time, adding and subtracting the equations does not eliminate x. So I decided, let me multiply the first equation by negative 2 so we can get the x to get eliminated. Okay, so now I've copied down the two equations. Okay, so we have, remember I took equation 2, we multiplied it by negative 2, that gives me negative 2x minus 4y minus 6z is negative 28. This is equation number 3, 2x plus 3y plus 2z is 14. Add them together, we get a negative y minus 4z equals negative 14. So now we have two equations with y and z in it. Okay, so now let's come back here, and we had the two equations, negative y minus 2z equals negative 8. We got that, and we also, by eliminating the x, we also got negative y minus 4z equals negative 14. Now we know what to do with this. This is a system of two equations with two unknowns. Let's take the top equation minus the bottom equation. Remember to distribute the negative, and you end up with 2z is equal to 6, z equals 3. Now that you have this, you can go back in and you can replace z with 3, and we end up with y equals 2. Go back to one of the original equations with three variables and we get x equals 1. So again, remember what the process is. Pick two equations, find a variable to eliminate. Pick another two equations, eliminate the same variable. Then you'll have a system of two equations with the same two unknowns, and you guys know what to do with that.